Good morning. Myself Ashagila Devi, Assistant Professor in Rohini College of Engineering and Technology. Today we are going to discuss about the subject CS 8792 Cryptography and Network Security. In Cryptography and Network Security subject, in Unit 4 we are going to discuss about SHA algorithm. So what is the outcome is, on successful completion of this module, the student should be able to explain the concept of SHA algorithm. So next we are going to discuss about the secure hash algorithm. The secure hash algorithm SHA is originally designed by NIST and NSA in 1993 and it was revised in 1995 as SHA-1 algorithm. So it is a US standard for the use of DSA signature. It is based on the design of MD5 with the key differences and it produces 160-bit hash value. And how this SHA works, what are the inputs and what is the output, that we are going to discuss. First, its digest length is 160 bit. The input text value is 512 bits and the subblock size is 32 bits and it uses 16 total subblocks and the number of rounds used is 4 rounds. Iteration per round is 20 and the chaining variables we are using is 5 into 32, that is 160 variables you are using, and the k constant value is either, that is k of t constant values, that is the t value ranges from 0 to 79, totally 80, and the output is, it produces a 32-bit block. We are going to discuss about the working of SHA algorithm. The first step is padding. Padding means we have to convert the message in the form of multiples of 512 bits. So to make it multiples of 512 bits, you are going to do this padding process. So what is padding is, the length of the message is 64 bits short of multiples of 512 bits after padding. So for this we are going to use the concept of appending, that is to make it 512 bits, multiples of 512 bits, we are using the appending concept. For appending we are going to use the 64-bit length value of the original message, normally it's taken. Then after converting the message in the form of multiples of 512 bits, you are going to divide that input into number of 512-bit blocks. So the next step is, you have to initialize CV. What is CV? CV is nothing but it's a chaining variable. It is a 5-word or a 160-bit buffer. So in this we are going to use some buffers, that is A, B, C, D, E. So you're going to store this chaining variable value inside that buffers. So consider A. In A we have stored the value 0, 1, 23, 45 and 67. In B we have stored 89, A, B, C, D, D, E, F. And in C, F, E, D, C, B, A 98. In D 76, 54, 32, 10. And E we have taken C3, D2, E1 and F0. So first you have to initialize all these chaining variables. So next we are going to discuss about the processing block. So here the actual algorithm begins. So first what we are going to do is, we are going to copy the chaining variable into a single register for storing the temporary, intermediate as well as the final results. Then divide the current 512 blocks into 16 sub-blocks. Each consists of 32 bits. So already we have divided the entire blocks into 512 blocks. These 512 blocks are once again divided into 16 sub-blocks, each of 32 bits length. Then you are going to perform some 4 rounds. Each round consists of 20 bits per iterations. So after performing each operation, we are going to expand the 16-bit word into 80-bit word. And for doing this, we are going to mix the k of t value, that is the k of t constant value. The t value ranges from 0 to 79. So it forms a new buffer value by adding the output to the input. So finally, the output of the hash value is the final buffer value. So this is a way how this SHA algorithm works.